Page 762, number 3. Find the instantaneous velocity at the indicated value of t. So our distance equation is s of t equals 3t minus 5, and we're looking at a time of 4 seconds. So what we want to find again is our change in distance over our change in time to get our velocity. Now the difference here is we want instantaneous velocity, which means we only want to look technically at one point. So that means we're going to change this a little, and we're going to take the limit as t gets closer and closer to 4, approaches 4. So how this is going to look algebraically is like this. So we're going to take the limit as t approaches 4, and we're going to use our slope equation. So we're going to use s of t, which we're going to change the t value, minus the value at our indicated t, which is 4. And we're going to divide that by that changing t minus our time of 4. So the reason we write it this way is because we want to be able to put in for t in the first part of this, here and here, of this expression, values that get closer and closer to the value of 4. So we want that to be kind of a sliding thing for us. So we're going to substitute and simplify, and we're hoping after we simplify that the limit will exist close to 4 so that we can find this instantaneous velocity. So we're going to substitute for s of t the 3t minus 5, and then we're going to subtract from that, substituting 4 into the equation. So we're going to do 3 times 4 minus 5 here, and then that's all going to be divided by t minus 4. So that's our change in our y2 minus y1 over x2 minus x1. So we're going to take the limit as t approaches 4 of 3t minus 5, and when we simplify here, we get a 7. So this is going to be minus 7, and that's all over t minus 4. So simplifying any more, we get the limit as t approaches 4 of 3t minus 12 over t minus 4. And we can factor out a 3 on the top. Remember, our goal is to simplify this fraction as much as possible. So 3 times t minus 4 over t minus 4. And so here is where we can see that the limit will exist because these can cancel out. It's not like we have 0 if we substitute t, because remember that t cannot equal 4. So we're okay there by canceling those factors out. So we're left with the limit as t approaches 4 of 3, which is a constant, so this has a value of 3. So that is our instantaneous velocity at t equals 4.